In previous lecture, we have discussed about the concept of delta connected three-phase system. In this lecture, we will solve some numerical questions on this concept. So let's see. So here it is the first question. A balanced delta connected load of 12 plus J9 ohms per phase is connected to a three-phase 400 volt supply. Find the line current, power factor, power drawn, reactive voltampere and total voltampere of the circuit. So let's see the solution. Here in this question, the impedance per phase is given as 12 plus K9. This is the impedance per phase. Here it is given in the form of rectangular format of complex notation, where 12 is the resistance per phase and 9 is the inductive reactance per phase, because here the sign is positive. We can convert this impedance to a polar format. So it will be 15 angle 36.87 degree. So this is the polar format of the impedance per phase. Next, in the question, the line voltage is given, that is VL is equal to 400 volt. And we know that in a delta connected system, for delta connected system, the line voltage is equal to the phase voltage. So it will be 400 volt. So the phase current I phase, it will be phase voltage upon phase impedance. The phase voltage here is 400 and the phase impedance is 15. Here we will consider only the magnitude of the impedance. We will not consider the phase angle. It is 400 by 15. And after solving it will be 26.67 ampere. In delta connected system, the line current is equal to root 3 times of the phase current. So it will be root 3 into 26.67. So we'll get the line current as 46.2 ampere. So this is the line current of the delta connected circuit. Next is the power factor. Here in the impedance, in the polar format of the impedance, we have seen that the phase angle is 36.87 degree. And remember one thing, this is the phase angle of the load. That is phi is here 36.87 degree. So the power factor of the load is cos phi, that is cos 36.87 degree. So we'll get the power factor of the circuit as 0.8 and it will be lagging, because in the impedance it is given that it is a resistive inductive circuit. Therefore the power factor should be the lagging power factor. Next is the active power. We know that the active power can be calculated as root 3 VL IL cos phi, or we can use 3 V phase I phase cos phi also. We can use any of the formula. So here it will be root 3 into line voltage is 400 into the line current, that is 46.2 into power factor, and the power factor is there 0.8. So we'll get the power as 25600 watt, or we can write the active power is 25.6 kilowatt. So this is the active power of the three-phase delta connected load. Similarly, the reactive power, that is Q, is root 3 VL IL sin phi. So it will be root 3 into 400 into line current, that is 46.2 into sin phi. So it will be sin 36.87 degree, because we have already seen that the phase angle here is 36.87. And after solving this value, we'll get the Q is equal to 19200 var, that is volt ampere reactive, or we can write Q is equal to 19.2 kVAR. So this is the reactive power of the circuit. And finally, the apparent power is, it is root 3 VL into IL. So root 3 into 400 into 46.2, and the value will be 32000 VA. That means the apparent power will be 32 kVA. So this is the solution for this question. In the next question, a balanced delta connected load takes the total power of 30 kilowatt at zero point 0.8 power factor lagging when connected to a symmetrical three-phase 400 volt 50 Hz supply. So find the circuit elements of the load per phase. So the solution here is, first of all, the values are given as the active power, that is P. It is 30 kilowatt, or we can write 30 into 1000 watt. The power factor is given here zero point 0.8 lagging. As the power factor is lagging, then definitely the nature of the circuit will be resistive inductive. So the nature of the load will be resistive inductive. Then the line voltage is given VL, it is 400, and we know that in a delta connected system the line voltage is also equal to the phase voltage, that is V phase, and also the frequency is given, that is 50 Hz. You have to find the circuit elements per phase, that means the resistance and inductance of the phase, per phase resistance and inductance. So first of all, the power formula is root 3 VL IL cos phi, that we know. So the IL can be written as P upon root 3 VL into cos phi. Here the P is 30,000 upon root 3 into VL, that is 400, into cos phi, that is the power factor 0.8. So after solving this, we will get the line current as 54.13 ampere. It will be the line current. And the phase current is, for a delta connected system, it will be line current upon root 3. It will be 54.13 upon root 3, and the value will be 31.25 ampere. So this is the phase current. Next is the phase impedance. The phase impedance is the phase voltage upon phase current, where the phase voltage is 400 and the phase current is 31.25. So we'll get the phase impedance, that will be 12.8 ohms per phase. Remember, this is the phase impedance. Now from the impedance triangle, the resistance per phase can be written as Z phase cos phi. So it will be 12.8 into cos phi, that is zero point 0.8. So the resistance here will be 10.24 ohms. For a resistive inductive circuit, we know that the impedance can be written as square root of R square plus XL square. So we can write XL equal to square root of Z square minus R square. Therefore, inductive reactance per phase will be square root of Z phase, that is 12.8 square, minus R phase, that is 10.24 square, and the value here will be 7.68 ohms. So this is the inductive reactance per phase, and the inductive reactance per phase can be written as 2 pi f L per phase. So it is 7.68. Therefore, the inductance per phase will be 7.68 upon 2 pi into f, and the frequency here is 50 Hz. After solving, the value will be 0.0244 Henry, or we can write 24.4 millihenry. Therefore, the answer is the resistance per phase is 10.24 ohms and the inductance per phase is 24.4 millihenry. So this is the answer. The next question is, three identical coils connected in delta across 400 volt 50 Hz three-phase supply takes a line current of 17.32 ampere at 0.8 lagging power factor. To calculate the phase current, resistance and inductance per phase and power by each coil. So here is the solution. First of all, the line voltage here is given, that is 400, and it will be also equal to the phase voltage because the connection is delta connected. The frequency given is 50 Hz and the power factor, that is cos phi, is given as 0.8 lagging. Lagging means again the circuit will be resistive inductive nature. So first of all, we can calculate one more thing. The current is given, that is the line current, and it is 17.32 ampere. So we can find the phase current, and it will be the line current upon root 3. That means 17.32 upon root 3. So the phase current will be 10 ampere. Now the impedance per phase, that is V phase upon I phase, where V phase is 400 and the I phase is 10. So the impedance per phase will be 40 ohms. Now again the resistance from the impedance triangle can be written as Z phase into cos phi. So it will be 40 into 0.8. So the resistance per phase will be 32 ohms. So this is the resistance per phase of the circuit. Here is the phase current. Next, the inductive reactance per phase, that can be written as Z phase sin phi. As the power factor, that is cos phi, is equal to 0.8, therefore the sin phi will be equal to 0.6. So the value here will be 24 ohms. As the cos phi is 0.8, so we can find the value of phi, that is cos inverse 0.8, and then the sin phi, it will give us 0.6. The value of XL is also written as 2 pi FL. It is 24. So the inductance per phase will be 24 upon 2 pi into F. Frequency here is 15. So the value of inductance per phase will be 0.07639 Henry. So the inductance per phase can also be written as 76.39 millihenry. It is the inductance per phase of the three-phase load. The last part here is the power by each coil. Remember, here we need not to find the total three-phase power, we have to find the power in each coil. And power in individual coil is nothing but the power of individual phase. So it can be written as V phase into I phase into cos phi. Here the value of V phase is 400, phase current is 10 ampere, and the power factor is 0.8. So after solving, it will be 3200 watt, or we can write 3.2 kilowatt. So this is the power per phase, or power in one coil. So that is the complete solution. Now the question number 4. Three similar coils, each having resistance of 10 ohms and inductance 0.0318 Henry in series, are connected in delta. The line voltage is 400 volt 50 Hz. So calculate the phase current, line current, power factor, and total power in the circuit. In this question, the resistance per phase is given, that is 10 ohms, and inductance per phase is also given, that is 0.0318 Henry. Also the line voltage VL is given 400 volt, frequency 50 Hz given. So first of all, we can find the inductive reactance per phase, and it is 2 pi f L. So it will be 2 pi into 50 into 0.0318. That is the value of inductive reactance. Inductance. We'll get the value of the inductive reactance as 10 ohms. So inductive reactance per phase will be equal to 10 ohms. Then the impedance per phase is square root of R square plus XL square. So it will be square root of 10 square plus 10 square. And after solving, the value will be 14.14 ohms. The current in phase, that is the phase current I phase, it is V phase upon Z phase, where V phase is equal to the value of VL, that is 400, because it is a delta connected system, and the impedance per phase is 14.14. So we'll get the phase current as 28.28 ampere. So for a delta connected system, the line current is root 3 times of the phase current. So it will be root 3 into 28.28. So the line current will get 49 ampere. This is the line current. Next is the power factor, that is cos phi, and power factor can be written as the ratio of resistance to impedance, that is R phase upon Z phase, where R phase is 10, Z phase is 14.14. So we'll get the power factor as 0.7072 lagging. It is lagging because the nature of the circuit is resistive inductive, that is already mentioned in the question. And finally, the total power, that is the active power, we can use the formula 3 I phase square into R phase, where the phase current is 28.28 square into R phase, that is 10. So we'll get the value of the active power as 24000 watt or 24 kilowatt. So this is the complete solution of the question.